So we found the period of the function, and we've also set that at exactly 16 grid lines from the right of 0. We did that because now we can break that 16 up into 4, chunks of 4, which makes it really easy to break the period up into quarters, right? And that's going to be where we find kind of our landmark points with these sine and cosine waves. Okay, so now it's just a question of figuring out the other features of the function, and also figuring out where we start, where we finish, and how we get there. So let's start with what we know. What is the midline of this function? We don't see a number being added out to the side, right? So it's kind of like we have a plus 0 out on the side. Therefore, it's like the midline is 0. So in other words, the x-axis itself, this line right here, that's going to be the vertical middle of the function. What's the amplitude? The amplitude is 2, right? So we'll go 2 units above and 2 units below the midline. And really what we care about from the midline and the amplitude is we want to find the maximum and the minimum. So what's the maximum value, the highest point on this function? It'll be exactly 2 units above the midline, so the maximum will fall at 2, positive 2 on the y-axis. What's the minimum? The minimum will fall exactly 2 units below the midline, so the minimum will be at negative 2. Okay. Now, right, we need to figure out where exactly our function is, right? We only need to plot 5 points, and all of those points are going to be at the values we've located. They're either going to fall on the midline, the maximum, or the minimum. And with respect to the x-axis, they're only going to fall at 0, or the fourth grid line, the 8th grid line, the 12th grid line, and the 16th grid line, right? Or in other words, at our quarter points for the period. But to figure out what goes where, we need to first know whether we're dealing with a sine or a cosine function. And we need to remember our patterns for the sine and cosine function, right? How do we recognize a wave? So sine wave, we remember, always starts at the midline, and it always ends at the midline. And as well, exactly halfway through its path, the sine wave is going to pass through the midline again. Okay. On the other hand, cosine is going to start at the maximum, or if it's flipped upside down, it will start at the minimum, right? Cosine is going to end at the maximum, or whatever extreme it started at. And halfway through its function, it will be at the opposite of that, right? So if it starts at the maximum and ends at the maximum, that means that halfway through, it will be at its minimum value. Okay. Sine, on the other hand, sine reaches its maximum at exactly the quarter point, which will be 4 grid lines into the function, right? And it reaches its minimum at its 3/4 point, which will be 12 grid lines in, right? On the other hand, those points for the period, that's where a cosine function would reach its midline or cross its midline. Okay. So we need to remember those patterns, and then we need to know which one we're dealing with for this specific function. Okay, so what are we dealing with here? We see cosine in the equation, so we know we're dealing with a cosine shape. So what does that tell us? At the start, our function is going to be at the maximum. Our maximum is 2, and our start is at x equals 0. So our very first point is going to go right there. What next, right? At our quarter point, the function is at the midline. Our midline is 0, and our quarter point is right here, right? 4 grid lines in. That's exactly why we set the period how we did. So that's our second point. Okay. What next? Cosine then proceeds on to the minimum, which we know is at -2 on the y-axis, right? So let's find -2, and now we're 8 grid lines in because that's halfway through our 16 grid line period. Where to next? Next, we're back onto the midline, which is going to fall 12 units in, or 12 grid lines in, and then we finish at the maximum, right? And our maximum happens at the end of the period we've set, which will be at the 16th grid line. And as soon as we do that, notice it gives us this nice, even sine wave shape. Okay. And then just to prove I'm not crazy, look at that.